Alright, so we should find the volume obtained by rotating the region enclosed by the graph y equals to x, y equals to x squared about the line x equals to 1. Alright, so it's about the line x equals to minus 1. And they say use the Dix or Washer method. Okay, let's sketch it. We've seen the sketch of this before, so that should be easy and straightforward. So let's just go ahead and do it quickly. So we know that we're going to have something that looks like this from the previous example we did, and we know that it intersects at the point 1. Alright, we have something like this, and we have the y value there of 1. Alright, so this is what we had before. Okay, and we see that this graph was y equals to x, and this is y equals to x squared. So that's what the shape looks like if you sketch it. Now, the rotation is about x equals to minus 1. So what I'm going to do is I'm going to indicate that this is minus 1, and this becomes my axis of rotation. So I'll put some dotted line to show that this is my axis of rotation. Very important, indicate your axis of rotation. And like I mentioned earlier, just draw the rotated piece. So I'll have a piece on this other side. Take note, if this is 0 to minus 1 is 1 unit, so I'll be somewhere there at minus 2, and from 1 all the way to minus 1 is 2 units. So it means that from here I have to extend it up to minus 3. So if we sketch the rotated piece, notice it, we're going to have something that looks like this. It goes all the way to minus 3, and you're going to have something that looks like this. There we go. That's the rotated piece. Now, how do you draw your disc? Like I said, you need to draw a disc that goes surface to surface. So just to demonstrate this, my first disc is just going to be from this outer surface that we have there up to this outer surface. There we go. That could be my first disc. My second disc would be the inner surface. So it goes all the way to this other graph and all the way there. There we go. Alright, you can draw a disc that looks like that, or any other disc that you draw, but it should be touching surface to surface. Now what we're interested is to know what this distance is from here all the way to there, and from here all the way to this graph there. So we need to find our outer edges, and we need to find our inner edges. Okay, so let's start with the inner edges. The inner edge is a distance from the axis of rotation all the way to the surface that is touching. Take note the distance from here to here is 1. You can see it's from a line to a line, so it's 1 plus the distance from here to this graph is just some, remember it's some horizontal distance, we can call it x. We don't know exactly what that is. Alright? However, take note, we're integrating here in terms of y. We're going to integrate in terms of y because if I stack this disc, notice it runs along the y direction. So you have to integrate in terms of y. So change this x to be a function in terms of y becomes 1 plus. Notice it, this is just a straight line graph y equals to x. So in the place of x, I can just put y. Here we go. That is your inner edges. Let's look at the outer edges. Again, there's a distance from here all the way to the parabola now. So first we know that we're going to have 1 from here to here, plus we're going to have this distance from here now all the way to the parabola. Again, if you look at it, it's just some unknown x value, but we can get x there again. So I'll just call this one x1 and I'll call this x2 just so that we can division there. x2 there's a parabola. We know that we integrate in terms of y, so it's just going to be 1 plus, you may x the subject there is just y to the power 5. There we go. There you have your outer and inner edges in terms of y. Now we define volume as the integral. Take note, because we integrate in terms of y, we need to look at the area in the y direction from 0 all the way to 1. So 0 to 1 pi outer radius squared minus inner radius squared dy. Alright, and if you square that and simplify, you should get pi over 2. Alright.